So think about the building you're in right now. The temperature is probably just right, the lights are on, you feel safe. Have you ever wondered what makes it all, work? Well, behind the scenes, there's this secret language that lets all the technology in a building talk to each other. It's called BACnet, and today we're going to decode it. But let's start with a feeling I know you've had. You get a new smart gadget for your home, and of course, it doesn't work with the stuff you already have. It's so frustrating, right? That feeling of things just not playing nicely together? Now imagine that problem but 100 times bigger, inside a skyscraper or an airport or a hospital.
Because yeah, that same frustration is magnified 1,000 times inside our buildings. They are packed with some of the most amazing technology, but for years, getting it all to cooperate has been a massive, expensive nightmare.
I mean, just think about it. A big, modern building is basically a small city of totally separate systems. You've got the lungs, the heating, ventilation, and air conditioning, or HVAC. You've got the eyes and ears, lighting, security cameras, key card access. And then you've got fire alarms, elevators. Each one is a supercritical, super complex system all on its own.
And here was the huge problem for decades. The companies that made all this stuff, your Siemens, your Honeywell, your Johnson Controls, they each built their systems to speak their own unique private language. It was like the HVAC system was speaking French, the lighting system only understood German, and the security system spoke Japanese. The result? Total chaos. The HVAC had no way to tell the lights that everybody left the room, so the lights just stayed on, burning money. It was a digital mess.
And out of that chaos came this truly brilliant solution, BACnet. It was designed from the ground up to be the universal translator, the one common language for every single device in a building.
Okay, so BACnet stands for Building Automation and Control Networks, and it's what we call an open communication standard. Now that little word open, that is the most important part of this whole story. It means no single company owns it. It's a public set of rules, like a shared dictionary, that lets equipment from completely different brands finally talk to each other and actually work together.
And look, this isn't some new, untested idea. People started working on this way back in 1987. It became an American national standard in 1995 and an international one in 2003. So this thing is mature, it's robust, and it's trusted all over the world.
So how does it actually do it? How does it get everyone to speak the same language? This is where it gets really, really clever. BACnet's big idea wasn't just to translate between languages, but to completely change how the systems think about the devices themselves. Instead of trying to deal with thousands of lines of custom proprietary code, BACnet does something much smarter. It represents every single piece of equipment or information or function as a standardized object. It basically takes the physical world and turns it into a digital format that anyone and any system can understand.
Let's make this super clear. See this physical temperature sensor in a room? BACnet looks at that and turns it into a standard analog input object. And that object has properties that are the same everywhere, like present value, which is just the current temperature, and its units, like degrees Celsius. All of a sudden, any system that speaks BACnet can look at that object and instantly know what it is and what it's saying. No custom programming, no translators, it just works.
And this model applies to absolutely everything. That temperature sensor? It's an analog input. A fan motor that's either on or off? That's a binary output. Even something as complex as the entire weekly schedule for the air conditioning is just another standard schedule object. Every single function in the whole building gets modeled in this simple, consistent, and understandable way.
Okay, so this object model is a neat idea, but it has a massive impact in the real world. This is what's making our buildings safer, way more efficient, and a lot more comfortable every single day.
Let's look at a pretty scary example of what happens when systems don't talk to each other. At a big swimming competition, people, athletes, fans, started getting sick. Their eyes were burning, they were having trouble breathing. What was the cause? A single piece of the HVAC equipment had failed, throwing the pool chemicals and air quality way off. An alarm probably did go off somewhere in a basement control room that nobody was looking at.
Now, let's just rewind that whole scenario, but with BACnet. The air quality sensors, the energy meters on the fans, and the main HVAC controllers would all be sharing their data as standard objects. A central system could have spotted it instantly. Air quality is dropping while a fan's energy use is spiking. That's a huge red flag. An alert could have been sent directly to an operator's phone before a single person felt their eyes start to itch. That is the real power of this.
And BACnet's flexibility also allows for some incredible innovation. I love this story. During the pandemic, engineers had to test the critical cooling systems for a huge new data center, but they couldn't travel to the site. So what did they do? They built this brilliant little virtual test kit, shipped it to the factory, and then used BACnet to run a full virtual witness test on every single unit, all from their home offices. You literally couldn't do that without a common, open protocol.
And you find this technology everywhere. In hospitals, where maintaining exact air pressure in operating rooms is life or death. In data centers, where a cooling failure could cost a company millions in minutes. In your office building, at the university campus, at the mall, BACnet is the invisible network that's just quietly keeping everything running the way it should.
Now, BACnet isn't the only game in town. You might hear about other protocols, like Modbus. The key difference here is really the scope. Modbus is super simple and tough, and it's perfect for basic tasks, like asking a power meter, hey, what's your current reading? But BACnet is designed for the whole ecosystem. It manages all the complex back-and-forth conversations between lighting, security, and HVAC across an entire building. It's the difference between asking one simple question and conducting an entire orchestra.
But you know, the biggest advantage of BACnet isn't just about what it does today. It's about what its open nature really means for the future of all of our buildings. The most important thing for building owners is that it helps them avoid something nasty called vendor lock-in. See, before BACnet, if you built your system with one company's proprietary tech, you were stuck. For every upgrade, every replacement part, every service call, you had to go back to them. You were locked in.
Well, BACnet completely shatters that lock. It gives building owners the flexibility to pick the absolute best, most innovative piece of equipment for the job, no matter who makes it. It means they can easily add new devices as their needs change. It guarantees everything will work together, and it truly future-proofs the massive investment that is a modern building's infrastructure.
So, the next time you're in a perfectly cool office or walking through a busy airport, just take a second to think about that invisible language making it all possible. BACnet proves that when things can finally talk to each other, they can become so much more than just the sum of their parts. It allows us to finally stop asking our buildings just to work and start asking them to be smarter.